All right, so let's look at this next example. Here it's sort of somehow clear that I want to at least consider polar because of all the radicals. So when you look at the region of integration, let's draw this together. So y equals either one of the radicals over here, y is equal to this one or that one, leads you to the equation x squared plus y squared equals 1. So we're working over the unit circle. I'm going to sketch it best I can. Something like that looks all right. Okay, so that's the equation. Y is going from the bottom portion of the unit circle up to the top portion of the unit circle. The key, though, is x. You can see x is going from -1 to 0. So what does that mean? It means that x is going from -1 to 0. We're on this side of the unit circle. So region of integration is circular, so definitely want to switch this thing to polar. And we can see what theta is actually swinging from pi halves over to 3 pi halves. And r is extending from length 0 out to length 1. So when I want to rewrite this guy in terms of polar, then I'm going to get integral, let's do double integral, e to the radical r squared is just e to the r, times r dr d theta. Dr goes, r goes from 0 to 1, theta goes from pi halves up to 3 pi halves. When I look at this problem, I realize I am going to have to do integration by parts. I think you guys can handle that, but still, let me get you going on it. Maybe I'll just do it. So u is r, and then I'm going to let dv be e to the r dr. And so what's going to happen here? Well, du is just dr, and v is just e to the r. So I can peel this integral out. This thing, I can separate this integral into the theta part and then the dr part. So this is going to be just the integral of pi halves to 3 pi halves d theta times the integral that we're interested in, and that becomes what uv, so r e to the r minus the integral from 0 to 1. I got to evaluate everything from 0 to 1. Integral 0 to 1 of v du, so just e to the r dr. All right, well, let's see. So this guy, this integral, is just going to be theta, and then evaluate. So 3 pi halves minus pi halves is 2 pi halves. I get just a pi. This integral over here, I plug in 1, I get what? Just e, so e. And then I'm going to subtract, and I plug in 0, I get 0. So e minus, okay, let's just work out this integral in our heads. The integral of e to the r is e to the r. Plug in 1, and you get e. So this is going to be minus e. And then you're going to plug in 0, and you get 1. So minus 1. And so this ends up being what? E minus e is 0, and then minus 1 is 1, so this is just pi. So the value of the double integral that we started with turns out to just be pi. And it would be pretty nasty to try to work that out directly. So I'll pause, I'll stop this one, and we'll do a couple more examples.